Welcome again to another episode of the Southwest Climate Podcast, Monsoon 2021 edition. Mike.
We made it.
Yeah, we did make it. I have to ask you, Mike, because you've been gone for 2 weeks. What are you doing, man?
I know.
What? You chose the wrong 2 weeks to go. Wow, what a start.
I know. I do this every year, and I always wonder why I do this every year. We go on vacation, visit family back in Michigan the beginning of July. You know what? In the back of my head, this is really a bit evil, Zach, but I was thinking, it'll be fine. The monsoon doesn't typically start till like the 15th anyways. There's going to be this grace period. You know, it's kind of rooting.
There's a warm-up period, right?
I was rooting for it to dry out. And I mean, you know, lived here for 20 years and plenty of seasons. You drift past the 4th of July and it dries out again and there's not much going on. And I was just couldn't believe it, man.
No, I
watched it from afar.
Yeah, that's an interesting juxtaposition between you and I, because, you know, I was highly disappointed by our Slack banter, and I'm like living this by myself. And it's been disappointing in that sense because, you know, we've mentioned this before of just how much of a visceral existential experience the monsoon is, but, you know, living it and talking about it is as much of the pleasure of it as experiencing it in real time. And you guys took that away from me. So
I know, you know, and I was with you in spirit because I was in Michigan with my radar app and I wasn't even paying attention to local weather. I was paying attention to Tucson weather. And I have to tell you a story too. So we went away and I bought one of those home cameras, you know, like the ones that get on the internet, you can put inside your house just to like keep an eye on stuff. You know, I was like, well, what if we have a leaky pipe or we can keep an eye on our cats? I actually watched one of the storms roll through. I pointed it outside and it was the one with the serious winds we had in Tucson. So I was watching my home weather station and watching it live. So that's how crazy
Atmospheric Sciences building has, as you know, obviously they have their camera set up. So you were probably looking at that too, huh?
I was. I mean, you could be on a space station, man. You could just live vicariously. I'm so glad to be back though. And we're in the soup for sure.
Well, that's awesome. Okay. So we gave a little bit of the hint away, but if people are tuning in and having been here, they already know what a great start to this monsoon it really has been. And boy, we needed it after last year. And it sort of reinvigorated me. It took a little while, to be honest. You know, after the first week and we had quite a bit of rain, I still wasn't into the flow. And I think I was still feeling the residuals from the shock from last year. But boy, I'm excited for it now. So what I wanted to do, Mike, is just kind of go over a couple questions. So what have been the defining characteristics of the monsoon season so far? Is July or has July been an all-timer? Okay. You know, will it be a 1 month wonder?
Oh,
yep. So let's sort of unpack those. All right. So before getting into what are the defining characteristics, I'll turn it over to you. Let me just summarize what we've seen so far from a sort of regional perspective. First of all, this is not just Tucson's been, you know, really active. This has been a kind of region-wide event. So far, if you look at the 110 or so stations, Mike, that you've amassed for us behind the scenes that we pay attention to, 88 of those 110 that are reporting right now have been above average. So that's for Arizona, New Mexico, right? Only 22 of them have thus seen below average precipitation. So that is a huge widespread event. And maybe I shouldn't call it an event. It's more regional. It's a persistent experience of the monsoon. You know, when you look at the sort of percentile ranks, another awesome figure that you've done for us, Mike, you have to really sort of search across Arizona and New Mexico to find areas that are below the median. You know, there's a few places east of Flagstaff, north of Show Low that look like they're right around median. Yuma area is below its long-term median, but of course, Yuma doesn't experience a lot of rainfall. Virtually no places in New Mexico have been below median. Again, not to bring up last year, but if you were to just juxtapose last year's entire season onto this, we're already better in a lot of places. through the first 3 weeks through July 19th than we have been all of last year. So,
dude, you say that again. Say that seriously. That is crazy.
Yeah, no, it's amazing. There's many places that have already experienced in the first 3 weeks more monsoon season rainfall than they did all of last year.
For the entire June 15th through September 30th period, some locations have already gotten more rainfall.
Yeah. Okay, so that's sort of the regional look, but other statistics that I looked at is just looking at sort of the aerial coverage by day of rainfall. And again, this is work that you've done. We're using a gridded data product, so looking at actual station measurements, but then interpolating in between those sparsely located stations. So kind of doing some statistics there to try to get a more spatially explicit picture of the monsoon. And for Arizona, in any one day, we have not yet had a spatial coverage that has been less than the long-term average. Okay, so every single day, more area has received rainfall than average.
Yep.
Okay, and sometimes a lot more. So, and I think we talked about this a little bit last month, just about the sort of spatial coverage and how the sort of time average of it, and the sort of peak of the coverages ramps up toward the last week in July, and that's sort of the peak in Arizona. And in any one day, sort of at that time period, the end of July, about 25% of Arizona is getting rainfall. And New Mexico, it's similar. It's a little bit higher. So the peak is not only higher, but it's actually slightly later. So it sort of ramps up until the peak is around July 1st, and then it ramps down. And on average, at that peak in New Mexico, about 37% of the state has experienced rainfall. So, and that's compared to Arizona, where it's only about 25%. But again, I think the point here is when you look at the spatial average, spatially, it's raining more in any one day than it does on average. And again, that just speaks to the fact that there's been a ton of moisture around, Mike, and maybe that's one of the defining characteristics. So within that context, in this first 3 weeks of the monsoon season being regional in scope and off to a really fast start, what's been the defining characteristics for you from afar?
Yeah, it has been from afar. And it's been watching my home weather station from Michigan, looking at the weather maps, looking at the radar. We left town just after the 4th. And, things had already started to shift around. And just last month, we had epic heat waves, big fires across Arizona. That yielded to an early sort of incursions of moisture. We were actually even seeing the dew points creep up third week of June and definitely into the last week in June. And it was, right around the 4th of July, even a couple of days prior, that the real deep subtropical moisture coming up out of the Gulf of California, so Gulf surge events, really started to kind of take hold. And subsequently, we've had reinforcing surges. And even over the last week and a half, it was right concurrent with me being gone, the really deep moisture settled into much of the Southwest. I think a lot of this, if you go back to what's a broad defining element so far, has been just a great position of the Four Corners high. And so that broad subtropical ridge, mid-levels of the atmosphere, has kept us in that mid-level easterly flow. And it's also been, there's been moisture to the east of us. So we've had deep moisture at the surface coming out of the Gulf of California. We haven't had much issue with drier air moving in from the east because it's been wet in New Mexico as well. And all those things converging, as well as that position of that ridge, has kept the lapse rate. So meaning that temperature rate as you go up in the atmosphere has been conducive for convection. And these little disturbances have been able to move around the high pressure system from the east towards us. All of those features together. And again, what you said, pointing back to that, just these really high moisture amounts for the beginning of July. The moisture amounts really you'd expect to see kind of that first week of August, second week of August. And that feels, Zach, right? Is just that it's so sticky. It feels like August. It was like that the first week of July, so that's just led to, frequent rounds of precipitation, even moving into the low desert regions, afternoon convection, overnight convection, waking up in the morning, and then storms firing off. Again, this is all activity you typically see in August, and we're doing it in the first 2 weeks of July.
So you said a lot there that I wanted just to unpack a little bit. One thing is, okay, so defining characteristic has been the apt position or the good position of the Four Corners High, basically to our north. Okay.
Yeah, and that's it's all linked to record heat to the north of us, right? So that it's all the same giant subtropical ridge. And the fact that it's not overhead and it's to the north of us, it's like a little topographic map where it starts to kind of go downhill again over us. And we're in that easterly flow. And that helps in so many ways as far as steering moisture, improving the convective environment, and supporting, good monsoon activity across Arizona and New Mexico. That
actually puts a damper on thinking about the monsoon, because now we've got to we've benefited in terms of monsoon rains and the aesthetics of the monsoon, but clearly there's been some northern impacts associated with that, including the heat waves, the fires. I mean, that really have stretched, up into northern Canada or into Canada.
For sure. If you're underneath that high pressure system, it's brutal.
And the other point that I always find is interesting, and that I always have to correct myself in thinking, is that as you move the position of that high to our north, we're under easterly flow. And that's different than what we typically are in the West, and that's like a defining characteristic of the monsoon. And so we get these these transient features that help with the dynamics of any one day and really help fire off the monsoon, and they come riding in from the east. And so you said that this year we haven't had a lot of, to our east, it hasn't been dry. So talk a little bit more about that. Do we often have drier air coming in from the east? And is this year anomalous in that sense, or?
I don't know. I mean, this is something that I've sort of struggled to get my head around over the years with the monsoon, is that, and so what we're talking about as far as easterly flow, it's mid to upper level. So it's not at the surface, right? Surface winds are super complex and are going to be driven by topography and pressure gradients and all those kinds of things. And you can have situations where those surface winds, when they're out of the east at the surface, that typically and I'm talking kind of Arizona now, is when they're moving through, you can work moisture through gaps. That's kind of the Chiricahua gap paper we've talked about in the past. But often if it's drier air, it will sink and compress and sort of dry things out. And then it can sometimes collide with moisture at the lower deserts, and you can actually have it as a focus for convection. That's been kind of discussed. Mike Luthold's discussion today was talking a little bit about that. But overall, that role of having, again, now we're in the easterlies here, which again is that's the monsoon system here, is us going from having southwesterly, mid-latitude kind of weather pattern to that ridge pushing north of us and then putting us into easterly flow, which is the same kind of easterly flow you'd see across the tropics, right? So we're in this sort of subtropical regime. And so, if that is overhead and sags a little bit south and starts to drag in dry air from the northeast, that can be problematic, but we haven't had that. We've had good, deep subtropical air mass east all the way through across New Mexico and into Texas. And looking at the accumulated precip over the last 30 days, it's wet in New Mexico, Texas. Much of Mexico is having a really good monsoon to date, and in Arizona. So we're kind of all in it together, and there aren't any sort of features being left behind.
So the other thing for me, one of the other defining characteristics has just been the persistence of, there's basically been no breaks. If you look at precipitation maps starting, at the end of June, there isn't any dry out.
Yes.
We haven't had the monsoon break yet that, we often have and will likely get at some point, and obviously those breaks happen when the position of the ridge sort of sinks back down south, shuts off that pump, puts us more in the westerlies, and so consequently we've just had really good high amounts of precipitable water around.
It's been interesting. If you look at the daily weather map, the 500 millibar weather map, so that kind of mid-level pressure pattern. We've had the ridge sort of build north. We've had the center of the ridge build to the northeast. We've had it build towards the northwest, which has given us that northeast steering flow across Arizona, New Mexico. That gives you your favorite kind of event, Zach, the rim shots.
The rim shot. Love the rim shot.
The northeast steering flow. The ridge has flattened out, and there have been little kind of disturbances at the top of this flat ridge, but they never pushed far enough to put us into the westerlies and dry us out. But what they actually did was become a focus for convection. So you end up having severe weather across northwest Arizona because there's lots of moisture, but then all of a sudden you had good dynamics, organizes those thunderstorms, and you get, really heavy flash flooding. So, last year we would have these little troughs of low pressure drop all the way down in the Southwest and just clean us out, right? They'd be like a broom and they'd push everything out, and then you dry out, and then you'd have to have the ridge rebuild. And it was just all that active pattern. That's just it's not anywhere near us this year with this just big sprawling high pressure system. And the little disturbances out of the westerlies are pretty weak, and they're not making it that far south. This is all great. This is what you want to see in a monsoon season.
Okay, going upstream though, and this is a question that I always like. It's a question that I never satisfactorily have answered, and that is, well, what's causing that? What's causing?
I know. I don't know. I don't know. I mean, I've been reading paper after paper to try to kind of tease it out. What's
driving that position of the ridge to be so persistently to our north in a favorable area? I mean, I think that's like the $20,000 question.
It is. And, why was last year, what were the larger hemispheric scale pattern issues there that gave us what we had? And then what's different this year? I mean, is ENSO part of this? It's neutral right now. What's the tropical forcing? It's probably weak, non-existent. What's going on all the way to the west here across the Pacific? I don't really know. I mean, I don't know.
Yeah. Well, it will be interesting when we, look back and do a retrospective on this monsoon, and if it doesn't keep up, or even if it's just average going forward, it's likely now to be an above average year, and it with the potential of it being, top 5 if we get rainfall persistently for the rest of the monsoon season. And I think it'll just speak to the variability within the monsoon. I mean, we would have then gone from a historically dry year to a pretty darn good one. And
this is really interesting. So we're July 20th, and you just called that we might have an above average monsoon season.
Yeah, I am calling that. I mean, listen, like if we were just playing the percentages right now, I mean, I think it's harder to get if we ran all the iterations, it's probably harder to get a below average monsoon season than it is to get an above average one.
That's interesting. That? Yeah. I suppose you're right. If you looked at the distribution, what you'd have to do is you'd have to pick from both the tails, right? So you'd have to pick from a low probability event that we're seeing now with the exact opposite low probability event, which would be like if it just stopped raining now across the Southwest through the end of the monsoon season, that would drop a lot of locations below average, if not. I mean, right now, like you said, most locations have already exceeded their totals from last monsoon, which was record dry. I mean, it would have to be so anomalously dry from here on out to even come close to below average.
Exactly. And I think maybe this is where we should incite 2017, my favorite year, because basically, and I'm just looking at Tucson as sort of a proxy for other areas, and they weren't all like this, but 2017 had a really epically wet 3-week period at the end of July. It started a little bit later than it did this year, and it basically ended in July. And in that time, I mean, if you just shut off the monsoon at that point, it would have been above average. And it almost did that in Tucson. There was one other main event, a relatively large event, but basically from mid-August to the end of September, it didn't rain in Tucson. And so there has been those years, 2017 being one of them, where, I mean, we get it all in a short period, but it's probably more likely that the rest of the monsoon looks like average than than the rest of the monsoon looks like last year. And so by that kind of logic, if I were betting on it right now, I'd bet that we have an above average monsoon.
That sounds like you're talking like a climatologist now. So you're just going.
I'm just playing the statistics here.
Yeah, you're going central limit theorem for the rest of the monsoon. I like it, man. I'm with you. On that.
Well, let's talk about that later, because I think we ought to think about and what the remainder of the monsoon is going to do. So let's get to that. But yeah, I wanted to go back to the sort of defining characteristics. The other thing that I've read a lot of, Mike, is this talk about the Gulf surge just hasn't shut off yet, and obviously that's related to the position of the ridge. That's related to the high precipitable water values. But basically, there's this constant, pump from the Gulf of California that's driven by the heating of the Colorado River Valley, let's say, in that area. So Yuma area, it sort of helps create these pressure gradients that allow for this constant seep. When the monsoon ridge is in a favorable position, that constant seep of moisture up into this area. But there's also other features that aid that, right? And when I think of a Gulf surge, I typically think of these eastward propagating short waves, or even like these tropical storms that move across the southern part of the Gulf of California and really sort of push the moisture up. But there's been a consistent and persistent Gulf surge.
Yeah, we pulled up some data this is reanalysis data. It's modeled data that is trying to assimilate all the observations. And, we just took a quick look at the anomalies. So how different is it from average? So measurement of precipitable water it's basically the integration of the moisture in the atmosphere from the surface up through the atmosphere. So it gives us an indication, because if you just think about dew point at the surface, sometimes you can have very dry air aloft and it will mix out and it doesn't produce anything. So if you've got moisture at all levels of the atmosphere, which is precipitable water, basically, if you take the column of atmosphere and are able to squeeze the water out of it, it gives you an indication how much water is in it. So it's it's the key metric, right, in measuring moisture during the monsoon season. But if we look at the graded estimates across all of North America right now, from July 1st through July 18th, across the Gulf of California, Southern California, Southern Arizona, well, actually all of the Southwest, and it extends over to Texas, everything is above average as far as moisture. And again, I think it really relates to having that big, broad ridge of high pressure so far north, and this nice, deep easterly flow has really shunted off the ability of the westerlies to kind of move in that dry air off the Pacific. So it's just kept us in this nice, constant soup of moisture for several weeks now.
That's a stark image in a good way.
Again, it's really unusual for this early, right? So July 1st through the middle of July is usually our ramp up period. The ridge is usually getting in a position, and we're usually sort of kicking off these surges as those storm systems move across northern Mexico and trigger that pressure gradient like you're talking about. We got that underway, and the Gulf of California sea surface temperatures were primed, lots of moisture there. Pressure gradient was there, and the moisture has just moved up and parked in the low deserts in Arizona, and have been a kind of a plentiful source. And Southern California has been in it too. So it's really kind of an indication that you're not getting any of that dry air from the Pacific moving across the deserts as it sometimes will, and it shoves that moisture back to the south and dries us out.
So one other thing that I wanted to talk about is just the spatial pattern and how anomalous and above average rainfall has been in eastern New Mexico. And a lot of that came sort of in the late June, early July period. But I wanted to talk about it in the context of the moisture surge and this high precipitable water, because normally when we think about the monsoon and these surges, like it's this low level moisture coming up from the Gulf of California that's then sort of wafting into southeastern, southern Arizona and southwestern New Mexico. And it's sort of being contained a little bit by the higher elevations, Mogollon Rim, sort of, and west of the Continental Divide, New Mexico. And it's sort of like helping to confine that moisture into that area. But on the east side of the Continental Divide, it's really been wet for New Mexico. And so what's been driving that? And do we think of that eastern part as a sort of as a different mechanism than the monsoon, or are they all sort of tied together?
New Mexico is, I think Continental Divide is kind of a useful dividing line, but the eastern part of New Mexico is really more Great Plains. And they tend to have more springtime precipitation related to Gulf of Mexico moisture and a low-level jet that forms there. And which you'll often see, you see this in the climatology, and it's pretty messy in the daily weather, but in the papers and when you look at climatological analysis, it's wet there first, and they dry out as the rest of the sort of Intermountain West, that would be kind of western New Mexico and Arizona, come online with the monsoon. And so they're often climatologically out of phase with each other. And so as we wet up, they dry out. And it's been kind of fits and starts, but late June, eastern New Mexico had a run of really wet days, and that kind of continued into early July. The moisture sort of shifted back towards us. And so it's been more kind of Arizona focused, especially over like the last week and a half. And so that sort of transition from their kind of springtime wet to our monsoon has brought great precipitation to much of the region. And we had an email from one of our listeners, Lynn, who just sent us some kind of amazing statistics from her place in Cloudcroft. She's up at about 7,000 feet. And she said that since June 27th, they've received 13.47 inches of rainfall at 7,000 feet. And they've had numerous flash floods. And they had a spring that dried up in 2018 with those really epic drought conditions actually start to flow again. I mean, just amazing in a 2-week period, going from what we were kind of experiencing across the Southwest all the way up into this new kind of wet regime we're in.
So another observation that I had, Mike, and this might be harder for you to speak to because you weren't around, but anecdotally, there was a number of mornings and late night storms and early morning storms so far than there has been. Obviously, maybe my memory is shaken by last year, and maybe it's last year just supplanted all of my recollections of early morning storms. But I really feel like, this year there's been more than normal. Do you have anything to say about that? Have you heard that elsewhere?
I mean, it's consistent with everything we've talked about, which is, great ridge position, these little mesoscale convective systems that will form. Sometimes they'll form in New Mexico, and they'll just gradually kind of move their way across southern New Mexico and into Arizona. And what will happen with those is they'll break out of the normal diurnal cycle. And so, typically climatologically in the monsoon, the early part of the monsoon it's usually mountain convection. So it's like storms forming over the mountains and then moving in the valleys if there's enough moisture. And then there's more moisture, they can move out to lower deserts. And if they get big enough, they'll turn into mesoscale convective systems. But we kind of jumped over all that, and we're in such deep moisture that these little mesoscale convective systems, they can go through the night and even into the next morning. It's real common in Mexico. And we typically don't see that kind of activity till later in July and early August, and sometimes into August. So it feels unusual for it to only be kind of mid to later in July now, and to already have all of those kinds of events already under our belt. I don't have a good climatology on that, but that would be a really interesting study to look at.
Well, it really changes the character of the rains, or how the rains form, right? Because it obviously shade in the morning and it's sort of kryptonite to the monsoon convection, right? Like it shuts off the ability of the sun to generate that heating that can drive the convection, but these mesoscale things, these larger phenomenon, regional features, they create their own dynamics. So you don't actually need the sun to be driving it.
They can help with, aiding the convective environment to sustain themselves. They don't need that. Well, they need the instability, and they need to move into environments that are unstable, so that have that kind of energy to be able to release. And often they'll have little outflow boundaries and little frontal systems associated with them that will fire off the new storms and kind of move them along. And again, you need really good deep moisture for those kinds of events to really turn into big rainers over large areas that go for long periods of time. We got it.
Yeah, and then the only other observation I had is, and I'm getting greedy here. Admittedly, I'm getting greedy, but I kept thinking, as I'm stepping out and the dew point temperatures and the humidity is really high, and it feels almost like we're not in Tucson, we're in some other place, and I'm like, boy, I just feel like we should be getting more rain, But I think that also speaks to how hard it is, even if there is persistent moisture around. It's really difficult to generate rain, consecutive days. Like the atmosphere just gets hung over. It doesn't have the thermal profile that's necessary. And so one thing that's been new to me, not new to me, but I've been spending more time like looking elsewhere, and every time I look at my app, like the radar app that you were mentioning before, and it's not raining in Tucson, like I see cells, like a whole bunch of cells elsewhere. It's just not raining here, but because there's so much rain, so much moisture around, it's raining somewhere else.
That's the interesting thing about Arizona in particular. And New Mexico is a little bit different because they got that kind of Great Plains driving, different patterns of topography. Our kind of pattern of topography here and having much lower deserts changes the convective environment. So mountains don't get hangovers. Like they reset every day, right? It can rain every day on a mountain. The valleys, though, can get worked over. And the lower deserts have even more challenging convective environments that they move into. So that's why the climatology of the precip maps look the way they do. And, it's been amazing to look just at the data across Tucson, because we've got gauges on the top of Mount Lemmon, which is our mountain range right to the north of the city, that have 6, almost 7 inches of precip in the last 3 weeks. And we've got places in town, which, as a crow flies would be about 10 miles, that maybe have a half inch. And they've seen, 3 or 4 10th-inch events. Like we've done pretty good at our house, but there are places in town that have done 4 inches, and we've got basically 1 3/4 inches at our house. So to me, that's the other, we're talking about these sort of widespread events, but even within these widespread convective events, there's really dramatic spatial variability, especially across the lower elevation locations.
Yeah, that's right. So before getting there, when you say the atmosphere just gets really worked over, so what does that look like?
The function of convection is to move energy and mass around, right? I mean, it's exhausting potential energy at the surface and turning it into kinetic energy through rising motion. And then you've got all this energy that's being released through condensation and then raining out, right? So when the atmosphere gets turned over, it's, basically taking away a lot of that potential energy that was stored up previously. So it's, what adds the energy back in is it's both. It's lots of solar heating at the surface can destabilize the environment. And it's much easier then to do that if you have a lot of moisture too. So you can actually add a lot of moisture into an environment and you need very little solar energy, and the environment is very, very convectively unstable. If you have less moisture, you actually need much more solar energy, and you get to a point where it's still not enough to actually kick anything off. And again, like from the climatology standpoint, in the monsoon season, climatologically, we're usually moving into deeper moisture through July, not like we've seen here early in July. So we just had tons of fuel in the form of moisture flow into the region early on, and it's just been great. It's made it pretty easy to kick off these widespread rain events and localized flash flooding. We've had some pretty damaging flash floods on burn scars across parts of the Southwest, and we're already seeing swift water rescues, and it's pretty early in the season to see all this kind of action.
Well, right, and you get just with all the rain, you get saturated soils, and it just makes for the subsequent events that just run off much more quick.
So that's a really good point too. Is that July 20th, moving into the rest of the season, the flash flooding potential is here now with any subsequent rainers that we get. We're not spending that time recharging soil right now.
All right, so I had a lot of fun with this prep this year because we're asking questions of it that are more enjoyable to dig into than last year. But Mike, I got to ask, do you think July so far has been an all-timer? And by that I mean, like, is this going to go in the books as a top 5, or has it been a top 5? You can answer either of those.
I think I do. I'm just looking at the data through July 20th across both Arizona and New Mexico. And the extent of the whole region that's below average right now is less than 25%. So that's a good sign. So that means 75% of the region has near average or above average precip, and almost half the region has above average precip right now. It kind of goes back to what you were talking about earlier. I think what's going to happen is, since we've got 10 days left in the month, that's pretty ample time to add to this. So I think it's going to be a top fiver.
Yeah. So you pulled this together. We just looked at going all the way back to the early 1900s, Mike. We looked at the top five Julys in Arizona, looking at sort of a regional average of precipitation.
Yeah. And it actually includes Western New Mexico too. So it's kind of like the core monsoon region. So, kind of Santa Fe to the Colorado River area.
Well, we'll have to come back with this next pod because we don't have all of July's data. So we can't actually put the current July into this context. But, the top five, and, maybe that there's some data issues here because you go back 100 years or so and the data itself gets a little wonky. But 1919 was number one, 1911, number two, 1921, number three, 1914, number four. And then 1999 was the fifth wettest July with a regional average. So I don't know, Mike, maybe we discount those first four just because that's going back, over 100 years, and the data itself gets a little more suspect then. But 1999 is perhaps an analog. And then I would add in 2017 as a nice analog. 2017 and that sort of regional picture comes in at the 15th wettest July on record. But certainly for Tucson, what's interesting about 2017, Mike, is that the Tucson airport got nailed. And so if you just were to look at the Tucson airport as the metric, it's probably giving you an overly optimistic picture, if that's the word you want to use.
Totally. Yep.
But I think, looking at 1999 and 2017 as analogs, comparing this monsoon to 2017, for example, 2017 in the Tucson area had a little bit more precipitable water. Again, it started, 2017 monsoon started a little bit later than it did this year, but it had 2 to 3 weeks of just really high precipitable water, slightly higher than we've had so far, but pretty darn comparable. The regional footprint of 2021 will have been better than 2017. So,
one thing I noticed that was kind of interesting, we were looking at this regional July totals, was that there's only been 3 years in the last decade that have had below average Julys for the region. And it was last year, so 2020, the previous year, 2019, and then 2016. And then all the other years, you've got to go back quite a ways to find another sort of, stinker of a July. And it was in the late 90s and early 2000s, we did end up having sort of a run of kind of bummer monsoons and bummer Julys. And it's really been in the last decade, things have kind of turned up on this sort of early monsoon season precip. And so it's going to be interesting to add in July of 2021 to this long-term time series to see how it sort of shakes out.
Okay, I found my map. So I looked at 2021 in comparison to 1999 in relation to Tucson, Phoenix, and Las Cruces. And the Tucson airport this year has actually been underperforming.
It really has. Yeah.
I'm really sort of bummed about this. I think to date, there's been just about an inch and 3/4. And Mike, you alluded to this before, but within Tucson proper, there's been values in central Tucson around close to 3 inches, actually a lot of 3 inches. As you move from sort of northeast to southwest, away from the Santa Catalinas, obviously it sort of generally it decreases in rainfall. Of course, there's a whole bunch of variability there, but yeah, like the airport itself has not been hit as other areas in Tucson has. And yeah, you mentioned before, top of Mount Lemmon, close to 7 inches. Eastern parts of Tucson, there's values from the Pima County Flood District of over 3 inches, 2 inches. So between 2 and 3 inches on the eastern side of Tucson. Yeah, but basically the airport is one of the lower values.
That happens for sure when you're using that single observation.
Yeah, so it's not such a great metric to compare the Tucson Airport 2021 to 1999, but yeah, there's a way to go. We're still lagging behind 1999 in Tucson. In Phoenix, 1999 at the Phoenix Airport had higher values than currently, and also in Las Cruces, it was slightly higher values than 2021. So we're not quite there. I mean, again, we'll have to piece this together when we have more regional data to see if it's going to be where it's going to come in. But if I were to bet right now, I'd say this is the top 5. This is going to be an all-timer.
I'm feeling pretty good about it now too, now that you kind of talked me into it. I don't like to drift too far from climatology, so I kind of need to move it off the mark every once in a while.
Well, I will say this one final point, looking again at the comparisons of this monsoon to 2017, not at one single location, but across the Tucson metro area where there's a whole bunch of flood control district automated weather stations. And again, we still have 10 days left, but I'd say, actually we did this math. If you sum up all of those stations, rainfall has been more so far in 2021 than it has in 2017. So by that metric, not just relying on the airport, 2021 is so far better than 2017, which in my mind has been the baseline for a good monsoon, at least the recent baseline.
Yeah, 2017, we've talked about this for years now, had good showy storms. I mean, I missed most of them, so I'm kind of looking for a good showy storm to kind of rear its head, especially in the next couple of weeks here.
So what about the next couple of weeks? Is this a one-hit wonder? Do you think this ends in, well, maybe we can talk about the next couple of weeks on the horizon that takes us to the end of July, and then think a little bit about what may be in store in August and September. What does the next couple of weeks look like?
I don't even know if it's worth talking about. I mean, because that the monsoon is so day to day. So there's some larger scale features that seem to be organizing themselves to make an up period across probably New Mexico and much of Arizona through the next 7 days. So that's really good. So the next 7 days puts us through, July 27th, 28th. So we're almost kind of rounding out the month. So that's kind of the weather time scale. It looks like more of the same, more widespread rainers, more heavy rain, more possible severe weather across much of the region going forward, just because we're seeing these really slow moving, broad features in the upper level flow kind of working their way from the east to the west across the Southwest.
Right. I mean, you bring up a good point. It is kind of a little bit of a folly to talk about the weather in the monsoon because it is so day to day. And obviously, rainfall is one of those things that we wouldn't want to overinterpret too much because it takes so much to just get the actual precipitation. But some of the broader features, so we talked about before the sort of position of the ridge, and those things have a little bit more persistence within them, do they not? So is there any indication, in the next 7 days that our pump, our surge might shut off, or are we still, in the immediate future under favorable environment for rain somewhere at least?
Yeah, I think we are. I mean, the thing to look for on the weather maps would be some kind of deeper trough that would put a lot of the region into the westerlies and would actually start to dry out the whole area, kind of move that deep moisture back to the south and to the southeast. Don't really see that. I was looking at the Climate Prediction Center's 6 to 10 and 8 to 14. They've got this, I had to click on the interactive map to see. They have a dry tilt. They have a tilt towards the drier tercile or towards the drier odds. And it's a 1% shift in the in the terticile, so it's not fairly confident. But if you look at the composite 500 millibar map, it actually moves the subtropical high off to the northeast, and that can be really useful for especially Arizona to get into deep southerly flow, that tends to favor more of western Arizona and areas north of there. So they actually have an increase of above average precipitation, increasing the odds of above average precipitation in the Great Basin.
What time scale is this for?
This is 6 to 10, and then 8 to 14. So you kind of see that out through the next couple of weeks, but it's definitely doesn't look like a shutdown. It doesn't look like a big reorganization and shift in the monsoon. And I've been playing with looking at the Climate Prediction Center, so part of NOAA, has their own climate forecast system, and it's called CFS. And they have forecasts out weeks to months. And I watched it in June, and they kept suggesting July was going to be wet across the Southwest, and it was right. And I was worried that it was going to flip over in August. So I keep watching the updates for August, and they still say August is above average. So it's like this persistent thing happening in the climate forecast system, just kind of carrying through the end of next month as well. Again, I'm not betting
on that.
Well, I actually am with Monsoon Fantasy, so I gotta get my guesses in. But it's running counter to the Climate Prediction Center's outlook for next month, which is below average for the Southwest.
So that leads to this question. I mean, do you think this can keep up? That a wet July will move into a wet August? I mean, that would be. I mean, that's not unprecedented. Obviously, it happens. No. I'm just sort of waiting for the Florida to fall away a little bit.
It will slow down, at some point. And so I'm looking at the 1 month outlook for August. Yeah. Made on July 15th. So last week, 5 days ago, is equal chances for Arizona, New Mexico. So I think they've kind of backed off on the dry August as well. I think it's a shrug. And I think it's because they're getting conflicting model results right now.
So you're going with a persistence of optimism, huh? So is that
it's weird. And you know what? Part of it is that it's happening early. It gets easier to kind of do stuff as you get later into July. That's not totally true, because last year blew up a lot of my conceptions of how the monsoon worked. Because I kept thinking that too. It's like, well, once you get to the beginning of August, it always rains, and it rains everywhere because you're deep. I mean, that was crazy to see that not the case. I guess my optimism is coming out of the broader North American flow pattern is so favorable right now. I mean, we'd have to see some really big kind of changes and start to see the jet stream really sag south and sort of shove in here to kind of move the ridge around. And it doesn't seem to be showing up yet.
And you don't think that can turn around on a dime?
I do think it can turn around on a dime. Absolutely. I could be totally wrong on this, but it's like this, it's a persistence forecast. That's absolutely, you're calling me out on it.
No, I love that forecast though, Mike. I really do, because
I do too. It's
more of the monsoon is just, it's good for our souls, I think.
I agree. It's an emotional forecast more than anything. It's not very scientific. I mean, honestly, when I put my bet in for Monsoon Fantasy, I'm probably going to hug Climo and maybe lean a little wet. That's as far as I'm going to go.
Well, so this will be interesting, because last month, when you looked at everyone that made a forecast in total for each of the 5 cities, a lot more people forecasted for below average than above average. It was like nearly 60-40 across each of the five cities. So everybody was, dealing with the bad memories from the year before, it seems like. And it'll be interesting to see if that flips this year, not this year, for August. Will more people sort of be on the optimism side of things and do that forecasting of persistence?
And will we get totally burned on that too? It'll be interesting.
I was looking at the CPC's forecast, and I was kind of playing the games in my head about, I'm just not sure that the monsoon engine can keep firing like this. And so in my estimates, I hedge more toward the dry side of things. But you made some compelling arguments that I might have to reformat that.
Monsoon engine's a good way of thinking about it too, right? Because it's kind of by mid-August, things do start to shift back around again. And the Northern Hemisphere is starting to think about fall at that point. So things can turn pretty quickly. And you start to see the importance of like tropical activity in the East Pacific kind of ramp up later in August. And if we don't have any, and if it's a below average season, it could get pretty quiet pretty quickly through August. So that'll be interesting to see.
Any other final parting shots? I mean, that was that was a very eventful first 3 weeks of the monsoon.
Yeah, lots to talk about, man. It's so much more fun when the seasons are like this. It's so much more fun when it's raining. We should get that on our t-shirts.
Okay. Well, let's come back in 3 weeks or so, and we'll recap July. We'll put July in that sort of historical context. We'll answer the question of whether or not it was indeed an all-timer. And, hopefully by then, we'll have a fair amount of August to talk about as well. And that'll take us to probably halfway through the monsoon, Mike.
Yep. We'll be halftime by then.
All right, Mike. Great to talk to you.
Thanks, Zach.
All right.
So much for half an hour.
I knew that was going to go long. I spent a lot of time this morning.
Between July, you know what? I think I did this plot wrong, Zach. So now that I'm talking about it,
I
have to go back to it.
It looked good.
It did look good, but I don't think it was right. I'm glad I didn't talk about it.